Example 1, an initial deposit of $8,000 made in a saving account for which the interest is compounded continuously. The balance will double in 8 years. What is the annual interest rate? So with me, you're not going to write this all down verbatim. We're going to put down just the important information. Remember, with compounded continuously, we're going to use A equals P times E raised to the RT. A is the outcome. It's how much money you have in an account after a specific amount of time based on what you invested and what the rate was. The initial amount is $8,000. We're going to replace P with $8,000. It tells us that the balance will double. If I take $8,000 and I double it, it means I'm taking it times 2. I'm left with $1,600. We want to know what is the interest rate. That means I want to know what is the R, and I know that this is invested for 8 years. I leave R here. We're taking R times 8. I'm going to demonstrate what is the minimal amount you need to show in order to receive credit. We're going to divide both sides by 8,000. 16,000 divided by 8,000 is 2. Now, in order to eliminate the E so you can solve for R, I'm going to take log base E to both the left and the right to keep the equation balanced. Another alternative way to write log base E is ln. So I'm going to take the ln to the left and to the right. On the right-hand side, the ln and the E will cancel. They really are going to simplify to 1. And we have 1 times R times 8. Now, how do I solve for R? I'm going to divide both sides by 8. Plugging this into your calculator matters. I'm going to demonstrate the wrong way and the right way to plug this in. Some students do this, please watch, and they're going to get the wrong answer because your calculator is going to generate an answer of the natural log of 2 divided by 8. We want the natural log of 2, enter, and then divide that quantity by 8. So the R is the rate, and we're going to put it into decimal form now. We're going to move the decimal 2 places to the right, and then we're going to look at the tenths. I can see I need to bump this up. So this is approximately 8.7%. At this time, I'd like you to turn to your homework. This would be lesson 4, and please complete problem number 1. Then come back to the video. This is example number 2, and it will match up with homework problem 2, but at this time, in your notes, let's go ahead and let's do this together. How long will you need to leave $1,250 in a continuously compounding account at 4.25% interest rate if you wish to triple the initial amount? So anytime we see continuously compounding, we are going to rely on this formula. Okay, so you're going to start with 1,250. This is your initial amount. Now, the A is the outcome after it's earned interest. So let's take 1,250, and it says we want to triple this amount. So let's take it times 3, and we know the outcome. The outcome is, again, the initial amount plus interest. Now, we have the percentage written as a decimal is 0.0425. We want to know how long does it need to be invested. That's the T in terms of years. So in order to solve this, the first thing I need to do is isolate the E. I'm going to divide both sides by 1,250. Now, I already know because I took it times 3. If I take 3,750 divided by 1,250, I end up with 3. So on the left-hand side, I have 3. In order to isolate the T, I need to take the log base E of both sides. Log base E is also known as ln. On the right-hand side, the log base E, or ln of E, and E are going to be simplified down to a 1, and I'm left with 0.0425 T equals the ln of 3. To isolate the T, I divide both sides by this decimal amount. And just as a quick reminder, like we looked at the previous example, I'm first going to do the ln of 3 and press enter, and then divide by 0.0425. So how much time? Approximately 25.8 years. T is in terms of years. At this time, please go back to Unit 8, Homework 4, which is exponential models, and please complete problem 2 before coming back to the video. So when we look at example number 3, first I'm going to read it. It took 4 years to earn $1,200 interest on an investment of $11,000 in a continuously compounding account. Determine the interest rate. So with me, let's please write down, because we see continuously compounding, A equals P times e to the RT. Remember, P is the initial amount, and I'm going to say A is the outcome. That means when you add interest onto the principal, that would be the outcome. So I start with $11,000 for the P, and then I earn $1,200 in interest. So to $11,000, that's why you invest money. You're earning interest, you're making extra money, or you hear money's working for you. We have $12,200. That's the outcome. Now, that's the outcome when you've invested for 4 years. We want to figure out what is the interest rate. So I'm going to start by dividing by 11,000. I do not want to round and then round again at the very end. The more times you round, the less accurate it will be. So if I take 12,200 and I divide it by 11,000, we can see it's not a terminating number. It's not a number that just stops. I would end up rounding here. I don't want to do that. So I'm going to leave this as 12,200 divided by 11,000. And then to eliminate the e, I will take log base e, also known as the ln, to both the left and to the right. On the right-hand side, the ln and the e are going to be eliminated, and I'm left with r times 4 equals the ln of 12,200 divided by 11,000. Now, on the left-hand side, I'm going to divide by 4. By dividing by 4, I've now isolated the r. How do I plug this into a calculator? First, I'm going to determine the numerator, and then I will divide it by 4. So I have the natural log of 12,200 divided by 11,000. I'm going to press enter and get an answer, and then divide it by 4. And now to this, I need to approximate. So I move the decimal 2 places to the right. I see 2.5, but when I peek behind the 5, the number behind it is greater than 5. So I need to round this to approximately 2.6%. Determine the interest rate, and we have done that. At this time, please go back to your homework and complete problem number 3 before revisiting the video. Right now, at example number 4, a continuously compounding savings account that pays 3.25% interest has $6,000 in it after 7 years. How much will there be after 12 years? It does not say what the initial amount was. So when I see continuously compounding, right away, A equals P times e to the RT. What I know is the savings account has this particular rate. So this is the rate, which I will turn into fully decimal form. This is the outcome right here. This is the outcome after 7 years. So let me replace those. We have 6,000 is the outcome. We don't know the initial amount. We know obviously it's less than 6,000. The rate is 0.0325, and it's going to be in there for 7 years. I want to first solve for P before I can go back and answer the next part. I know that this part that I'm putting a parenthesis around, this is a value, right? E is a number, and I'm raising it to a value. So right now, with me on the calculator, please press clear. To achieve E, you hit the blue key and go straight down that same column to where you find E of X, and 0.0325 times 7. That's this amount right here that my finger's over. So I really have 6,000 times P, whatever this value is. I'm going to divide by that value in order to isolate the P. How do I take and copy and paste this? You type in 6,000 divided by, and we do have a copy and paste button. You're going to hit the blue key and go directly below the 3, copy and paste. So the initial amount is approximately $4,779.13. This problem does not ask for initial amount. It says, how much will there be after 12 years? So we're going to reset this problem back up with A equals P e to the RT. We now know that the initial amount is $4,779.13. We know the rate is 0.0325, and we know the number of years they want us to invest it is 12. We want to know what is the outcome when this is the case. I'm going to start by first achieving this amount and then taking it times the $4,779.13. So E raised to the 0.0325 times 12, press enter, then taking it times that initial investment of $4,779.13. So we can say after 12 years there will be approximately $7,058.68. Please press pause and complete problem number 4 from the homework. Moving on right now to example number 5. Example number 5 says, so example 5 is like example 4 and like the future example number 6. A deposit of $3,200 in a continuously compounding account has turned into $5,000. Now, how does it turn into $5,000? Because of the interest it's earned. Initial, so this is your P, and this is your outcome, your A, after 9 years. How long will it take to reach $8,000? So very much like example number 4, we start with A equals P times E to the RT. You're welcome just to watch unless it helps you learn by writing it down. You invest $3,200. The outcome, again, is $5,000. So it obviously has earned interest. Now, what is the interest? We don't know. All we know is that it remained in there for 9 years. I can now solve for R. I start by dividing by 3,200. 5,000 divided by 3,200 equals E to the R times 9. Now, it's possible I could take 5,000 and see, does 5,000 divided by 3,200 equal a terminal decimal? It does, it does. So if I want to, I can leave it like this, or I could represent it in equivalent fashion like so. Okay, we want to solve for R. How do we get rid of the E? We're going to take log base E, also known as ln, to both sides. The ln and the E are going to be eliminated on the right-hand side. R times 9 equals this quantity. And then I'm going to divide by 9. And like I said in the first 2 examples, first I'll figure out what is the numerator, and then I'll divide it by 9. That's the first part of this problem, just figuring out the rate. So ln of 1.5625, press enter, then divided by 9. So my R is approximately, move it 2 places to the right, we can see the 4.9, but look at, behind the 9 is a 5, 5 or greater, we bump up. So instead of being 4.9, it's going to be approximately 5.0%. Be careful, like we've learned, a lot of times students go through the motion of answering this, but they don't look back up. What does the question ask for? How long will it take to reach 8,000? So let's go back to this basic formula here. We have A equals P E to the RT. We know the initial amount is 3,200. We now know the rate to be 5%, so 0.05. And we want to know how long will it take, that's the T value, how long will it take to have an outcome of 8,000? Okay, so here we go. Dividing by 3,200, dividing by 3,200. Let's see if this equals a terminal decimal. Terminal decimals will be decimals we don't have to round. It does equal terminal decimal, so I have 2.5 equals E to the 0.05 times T. How do I eliminate the E? I'm going to take the ln of both sides. And now I have 0.05 is equal to the ln of 2.5 divided by 0.05. And on my calculator, I can take the ln of 2.5 and make sure to press enter, then divide it by the 0.05. Okay, how long? It will take approximately 18.3 years to achieve the 8,000 based on this criteria. At this time, please press pause on this video and please complete problem number 5 in the homework. Example number 6. An investment of $4,000 doubles after sitting in a continuously compounding account for 11 years. How much will be in the account in 18 years? Okay, so we see continuously compounding. Right away, I know I'm using this formula. A equals P raised to the, A equals P times E raised to the RT. The initial amount is $4,000. It's doubled. So if I double, the outcome would be 8,000, because if you double or take 4,000 times 2, we're at 8,000. It's in the account for 11 years, so I'm going to replace the T with 11. Now I'm going to go ahead and I'm going to solve for R at this time. So I divide by 4,000. 8,000 divided by 4,000 is 2. And now to isolate the, I forgot to put in 11 here. In order to isolate the R, I'm going to take the ln of both the left and the right. And in doing so, the ln of E on the right is going to be eliminated essentially. And I have the ln of 2 equals R times 11. Divide by 11, divide by 11, and now grab that calculator. As a quick reminder, we're going to take the ln of 2, press enter, and then divide by 11. I think a lot of students will think they have achieved the correct answer and stop right now. The question says how much will be in the account after 11 years. So I'm going to go back here, and I'm going to set this up. I have A equals P, E to RT. We know the initial amount is 4,000. We know the rate is 6.3, but as a decimal, it's 0.063. We're going to leave it in for 18 years, and let's figure out what is this outcome. So I'm going to do this portion first. E raised to the 0.063 times 18. Now I'm going to take it times the 4,000, and we could say the outcome would be approximately $12,432.26. At this time, please complete problem number 6 from the homework and check for accuracy.